before the day's over. I'm kind of mad at the person who's been changing my background. So he put something on the board that could have got me in a lot of trouble. So we'll have a talk with him later on. So it was all funny until today. All right. Here we go. Last example. Find the area bound or volume of the area bounded by y equals x squared and y equals x revolved around the x-axis. What does y equals squared look like? Y equals x squared. Parabola, yep. And y equals x. Not always. Well, because the line wouldn't intersect that other side. You want the area bounded. And if we draw the parabola over here, which we can, you can see that this is still the area bounded by. Okay. So here's the deal. This is the super important part. Shh. Okay. We're going to do this problem using the cylindrical method, but there's another way to do this, and on the test, you get your choice. So if I rotate this around the x-axis, okay, I'm going to get that shape down there, right? Now, what method do we already know how to use in order to find that volume? The washer method, but we're going to do it using cylindrical shells. Oh, sorry. All right, Morgan knew I made a mistake. Very good. Okay, how's that? Thank you. So you can use the washer method. If you get this problem on the test, go ahead and use the washer method. I'm going to teach you how to also do it using the cylindrical shell method. The problems you did yesterday that we did as notes, you can't use the washer method on those. Okay? Because the inside radius and the outside radius come from the same function. So what we're going to do is we are going to use the shell method for this final problem. And when we use the shell method and we rotate it, we are going to cut it like this. And we're going to take that little piece that we cut and we're going to rotate it down here. I don't know, I'm not doing the best job drawing this, but that's kind of the idea. Okay? You see that? So, let's unravel it. When you unravel it, what kind of shape are you going to get? Yeah. So, I'll unravel it. It'll kind of unravel like this. Very good. Okay, so Anna sees that this sliver that I cut right there, does that have width of dx or dy? dy. So everything has to be written as a variable with y. So I have to change y equals x squared to x equals the root of y. And I have to change y equals x to x equals y. So, let's look at this. The last piece, and this is kind of different. How do I come up with this width right here? This width is the same as this, is it not? And in order to get that, I have to do right minus left. So the right function is the root of y. The left function is y. Now, my radius, this is just some y value for a height, correct? So I've chosen some y value for a height, and this line of my rotation is y equals 0. So what's the radius going to be? Y minus 0, which is y. So the circumference will then be 2 pi y. So I've unraveled my cylindrical shell to be that type of a shape. I'm now going to go ahead and integrate. I have my 2 pi. I have my y. I'm going to multiply by the root of y minus y dy. What are my bounds? Zero to y1. This intersection point right here comes out to be 1, 1, and so y is the height. So 0 to 1, very good. So I've set up the integral. Now it's time to integrate. Two pi times the integral from 0 to 1. Let us distribute. What's y times the root of y? Y to 3 halves minus y squared dy 2 pi. What's the antiderivative of y to the 3 halves? Very good. 2y to the 5 halves over 5. Minus what? Y to the what? Third over 3. And reevaluate that. 0 to 1. You know that when you plug in 0, you get 0. What's my common denominator between these two? 15, so we'll turn it into 15ths. I plug in 1. I get 2 pi times 1 to the 5 halves is 1 times 2 over 5, be 2/5. Turn that into 15ths. 6 over 15. Minus. What's 1 to the 3rd? 1 divided by 3. 1/3, turn in 15ths. 5/15. So we get 6/15 minus 5/15 is 1/15. So you end up with 2 pi over 15. That is the exact volume of that shaded region rotated around. Okay. My point is this, is that as opposed, some people don't use the washer method at all. And I stopped using the washer method in college. I just always did the problems like this. The material. Yeah, you're not finding the volume of, like if you were to say dump water in there, how much water could you hold? It's the material that you're using to make it. Okay, so I think I wrote down a few problems yesterday. I just have 3 more for you to do. You're going to be given time on Monday to work on any problems that you have. I'll give you a study guide as well. Next week is time to practice everything. So next week is where you got to say, okay, I got to get my ducks in order and get this stuff figured out. So can somebody tell me what I wrote down yesterday? 6.3 page 396. And what did I give you yesterday? 3 through 6? And then we hit a home run. We don't do homework. And then I wrote down 3 more problems. Did anybody write them down? So 15, 17, and 18. And some of those you can do using the washer method. However, I want you to use the cylindrical shell method. Now, Megan, you had a question yesterday, right, on problem number 4, I think? So if you have questions on the material, I could take them at this point. Otherwise, you do have a little bit of time here to work. No, the sine and cosine wash runs we don't know how to do yet. There are answers, but no, we're not how to do them for another couple weeks. Yep, it's under my book right there.